Hello everyone, we will explain about differential line surface and volume. By integrating line surface or volume, the range of the variable define the limit of the integration. In order to evaluate the integral, we must define the differential length, surface and volume in the coordinate system. The definition of the differential element of line integral dl and surface integral ds can be determined from differential volume integral dv in the coordinate system.
Firstly, for rectangular coordinate, dv equal to dx times dy times dz. For cylindrical coordinate, dv equal to d rho times rho dv times dz. Third one, spherical coordinate, dv equal to dr times r d theta times r sin theta d phi.
The differential surface ds is the area of the surface element and a unit vector normal to the surface, which directed away from the volume if ds is part of the surface describing a volume. If we consider surface A, B, C, D in figure shown, for example ds is equal to dy, dz, ax, whereas for surface P, Q, R, S, ds is equal to negative dy, dz, ax, because n is equal to negative ax is normal to PQRS.
For the example A, the circumference of a circle of the radius is, after we calculate, we get 2 pi rho naught.
For question B, the surface area of a sphere of radius r naught is 4 pi r square. The answer is equal to double integrate ds is equal to integrate phi is equal to 0 to 2 pi integrate theta is equal to 0 to pi r naught squared sin theta d phi. We will get an answer s is equal to 4 pi r naught squared.
For question C, the volume of sphere of radius r naught is 4 over 3 pi r naught cube. Voltage is equal to triple integral dv, which is equal to integrate phi 0 to pi integrate theta 0 pi integrate r equal to 0 r naught r squared sin theta dr d theta d phi, and the answer is equal to 4 over 3 pi r naught cube.
Certain parameters in electromagnetic are defined in terms of the line integral of a vector field component in the direction of a given path. The component of a vector along a given path is found using the dot product. The resulting scalar function is integrated along the path to obtain the desired result. The line integral of the vector A along A, the path L, is then defined as where dl equal to al dl. A line unit vector in the direction of the path L, dl differential element of length along the path L, A dot dl equal to A dot al dl equal to al dl. Example for line integral, given h equal to in bracket xy ax plus in bracket x squared plus zy ay plus in bracket 5yz ax. Evaluate the line integral of h along the path L made up of the three straight line paths shown below. On L1, y equal to 0, z equal to 0. For the answer is h1 dl1 equal to x dx. On L2, x equal to 0, y equal to 0. h2 the L2 equal to 0. On L3, x equal to 0, z equal to minus 1 over 2y plus 1 equal to 1 minus y over 2. For the answer is minus 3 over 2y in bracket 1 minus y over 2 dy. Integrate h dl equal to minus 1.5.
Surface integral of vector. As we know, certain parameters in electromagnetic are defined as the integral of vector. As we know, certain parameters in electromagnetic are defined as the surface integral of vector field component normal to the surface. The component of a vector normal to the surface is using dot product. The resulting scalar function is integrated over the surface. It also defined as surface integral of A over S equal to double integral S A ds. From example given, we can use the equation surface integral A ds equal to integral S1 A1 ds1 plus integral S2 A2 ds2. We can assume that S1 equal to S equal to S1 plus S2, where S1 is hemispherical surface and R0 equal to 5. S2 is circular surface where theta naught equal to 90 degree. Next, we need to find the S1 and the S2. From equation, spherical coordinate differential volume dV equal to dr times r d theta times r sin theta d theta. We get the value of the S1 and the S2. So we can calculate the surface of integral by substitute back into equation to get the value.
Now we move on to the volume integral. The volume of a three-dimensional region V is simplified. V equal to volume integral dV. We shall now express it in terms of surface integral over S. In the figure shown above, a general volume V containing the origin and bounded by the closed surface S. Let us suppose that the origin O is contained within the V. Then the volume of the small shaded cone is dV equal to 1 over 3 R times ds. The total volume of the region is then given by volume equal to 1 over 3 surface integral R times ds. Now we move on to the example 1. Find the volume enclosed between a sphere of radius A centered on the origin and a circular cone of half angle alpha with its vertex at the origin. Now ds equal to a squared sine theta d theta d phi r cap, taking the axis of the cone to lie along the z-axis, from which theta is measured. Then required volume is given by volume equal to 1 over 3 surface integral r times d, and we get 2 pi a cubed over 3 1 minus cos alpha. Thank you.